Problem 23 from chapter 27. Shut up. Could I have your attention, please? I will read from the book of Giancoli, 27, Modern Physics. The threshold wavelength for emission of electrons from a given surface is 320 nanometers. What will be the maximum kinetic energy of ejected electrons? And the wavelength is changed from 250 nanometers and 350 nanometers. And this is sort of a trick question because one of the answers is going to be that there's going to be some energy, and the other answer will be that it's not enough energy to eject electrons at all. But first off, what do they mean by threshold frequency? What is that? What are they talking about? Threshold frequency corresponds to wavelength, right? So the shorter the wavelength, the bigger the energy, correct? Okay, so threshold frequency or threshold wavelength, right? What they're talking about is that photons with not energy less than that don't eject electrons at all. Why not? They don't have enough energy to do what? To get them off the surface, right? There's something called the work function, and literally that's the work needed to take an electron from where it is orbiting its happy little atom to away from the atom infinitely far as the atom is concerned, right? Yes? Okay. So this is related to binding energy. I would say they're the same thing, but I'm really not a chemist. So, but it's related to something like activation energy, right? So if these things, this threshold wavelength, if they've got an energy less than that, then they can't, the work function, then they can't eject electrons. If they got more, then the electrons are ejected with some kinetic energy. So what is the meaning of that? The energy of the threshold wavelength is what? The energy of the threshold wavelength is what? Least amount of energy is also known as what? The work function. There we go. Right? So the first thing to do is to take that 320 nanometers, if they ever give you a threshold frequency or wavelength, right, and turn it into electron volts. And is that what this is? No, that's what this is. Is that right? Yeah. Okay, so that energy corresponds to 3.88 electron volts, right? Now from there on, it's just a regular run-of-the-mill photoelectric effect problem. They give you 250 nanometers. You figure out that it's this many electron volts, right? And so the energy released is this minus this is that, right? That's the energy that the kinetic energy that they have, okay? So we can just subtract. This is photon energy minus work function is kinetic energy of the electrons released, maximum kinetic energy, right? Okay. So the overarching relationship, right, is that photon energy turns into work plus Ke, right? And so they're just saying Ke is photon minus work, right? Okay. How about, so that's the 250 nanometer one. How about the 350 nanometer one? Not enough energy. How do you know? Well, it's a bigger wavelength than the threshold. Bigger is less energy. If it's less energy than the threshold, then it doesn't release them at all. What do? They just go, yeah? They're like, woo, but their feet don't leave the ground, yeah? Like, whereas the other one is like, I'm gone, right? Oh, well, it just depends, you know. I don't know. The key is to get the look on their face, kind of a thing like that, right?